In this problem, we need to find out the value of cube root of the complex number 1 plus iota as well as the fifth root of the complex number. So we will begin by considering a complex number to be equivalent to z. That means z will be equals to 1 plus I. So the first goal will be to convert the given complex number to its polar form. To find out the polar form, that means we want to represent z in the form of r multiplied to cosine of theta plus iota times sine theta. For this, we need to find out the value of r as well as theta. R can be obtained by simply, we will take the square root, and within the square root, we will take the real part, square it and add it to the square of the imaginary part. This is going to give us the value square root of 2. Then we will find out the value theta. So theta is actually argument of our complex number z, which is also defined as the inverse tangent or the arc tangent of the real part divided by the imaginary part. So we have tangent inverse of 1. Now we know that tangent of pi over 4, so that value is equals to 1. So in place of 1, we are replacing with the tangent of pi over 4. This is done. So the tangent inverse of tangent of pi over 4 simply becomes pi over 4. So this is the value of our argument theta. Now that we have our value of r and theta, we can represent 1 in our polar form as z equals to square root of 2 multiplied to cosine of pi over 4 plus iota times sine pi over 4. Now using the fact that cosine and sine are periodic functions, that means cosine of 2 pi m plus pi over 4. So this is also equals to cosine of pi over 4, and similarly sine 2 pi m plus pi over 4. So this is also going to be equals to sine pi over 4. So here m can take the value 0, 1, 2. Now we can rewrite our complex number in the polar form as z equals to square root of 2 multiplied to cosine of, so instead of pi over 4, we'll replace it with 2 pi m plus pi over 4 plus iota times sine 2 pi m plus pi over 4. So this is the polar form of our complex number z. Now we will raise it to the power of 1 over n. That means we will consider the nth root of a complex number z, which is z raised to the power of 1 over n. So we are going to get, so square root of 2 is actually 2 raised to the power of half. So we are raising it to the power of 1 over n, so we'll get 1 over 2n multiplied to cosine of 1 over n multiplied to 2 pi m plus pi over 4 plus iota times sine 1 over n multiplied to 2 pi m plus pi over 4. And this is entire thing is multiplied to 2 raised to the power of 1 over 2n. So here what we have done here is we have used De Moivre's theorem. The De Moivre's theorem simply states that whenever we have cosine of theta plus iota times sine theta raised to the power of n, so that's equals to cosine of n theta plus iota times sine of n theta. So in your case, we have multiplied with 1 over n because that was the power of the complex number z. Now that we have the general form, so let's rewrite it. So we will have the nth root of our complex number z, so that's given by 2 raised to the power of 1 over 2n whole multiplied to cosine of, we have 2 pi m plus pi over 4. So let's this will be pi over 4n divided by, so 2 pi m will be divided by n plus iota times sine. So we have 2 pi m divided by n plus pi over 4n. So we will use this. Now we will take case number 1. So let the n value be equals to 3. So when n equals to 3, this means that we have to find out the cube root of a complex number z. So when we need to find out the cube root of complex number z, then we are going to consider 3 values for m. So m will be equals to 0, 1 and 2. So let's use this. First we will use the value of n equals to 3. So this is going to give us, we have z raised to the power of 1/3. So that will be equals to 2 raised to the power of 1/6 whole multiplied to cosine of 2 pi m over 3 plus pi over 12 plus iota times sine 2 pi m over n. So n value will be 3 plus pi over 12. So this is going to be the cube root of a complex number where z is given by 1 plus iota. So this is going to be root. So for different values of m with 0, 1 and 2, this is going to be the solution. So I am giving here the general solution. To find out the particular solution, we can replace each value of m with 0, 1 and 2. This is going to give us the 3 cube roots of a complex number z. Then we'll go to the second case. In the second case, we will going to consider the n value equals to 5. That means we have 1 plus iota. So that actually 1 plus iota is the complex number z raised to the power of 1/5. We will use this particular equation. So this will be 2 raised to the power of, so we have 1 divided by 2n. So that means 1/10 multiplied to cosine of, so with 2 pi m divided by n. So n value is 5 plus pi over 20 plus iota times sine 2 pi m over 5 plus pi over 20. Now here we have to find out the fifth root of a complex number z. So that means we have to consider 5 values of m. So here m can take the value 0, 1, 2, 3 and 4. So for these 5 different values of m, we will get 5 distinct fifth root of a complex number 1 plus iota.